Today, we will be presenting our group's database study and optimization project. Our group consists of Catherine Seaman and Elise Depew. We chose to do our database project using a company called Genevive Physician Group. Genevive is a geriatric primary care physician group where Elise Depew is employed as a medical coding specialist. This clinic uses Advanced MD as their practice management system. Advanced MD supports scheduling and billing, and it also interfaces with the company's electronic health record system. We interviewed Genevieve's revenue cycle and data manager, Abby Kaiser, to determine how Abby and the billing office utilized the software to complete daily tasks, pull reports, and store data. Abby reports that although they just went live with this system recently, the system is meeting the initial needs of the revenue cycle department and interfaces well with the company's electronic health record system. We thoroughly reviewed the demographic, billing, and appointment information aspects of the Advanced MD database and how these functions intersect with each other. We also reviewed Advanced MD's website to review functionalities and researched electronic health record literature to further familiarize ourselves with the purpose of electronic health record systems and practice management systems and the impact that these systems have had on the healthcare industry. Our objective was to gain knowledge by researching the benefits and drawbacks that others have experienced with these systems and use this knowledge to improve upon the current database. Right now, the Advanced MD database functions include both billing and scheduling functions. Billing functions include the storage of patient demographic information and billing for services and collecting payments. We added a couple of billing functions with our database design optimization, including a credentialing organization function and a billing fraud and abuse protection function. The credentialing function will allow providers to be stored as either credentialed or non-credentialed, and therefore bills can be held until their insurance credentialing process is complete. The billing fraud and abuse protection function will allow users to view bills that are outliers when compared with Genevieve's average billing amount. These bills can be reviewed and audited if necessary. Both of these added functions will help optimize reimbursement and compliance while reducing risk for the organization. The Advanced MD database stores patient demographic information, including name, contact info, insurance info, and whether or not they have a financial guarantor, referred to throughout the database as responsible party. It stores provider information, including NPI, name, contact info, and Medicare credentialing status. It stores insurance company information, including insurance identifier, address, and claim summary. It stores appointment information as it pertains to billing services, including date of service, appointment type, and status, and billing and payment information, including bill status, bill responsibility, payment amount, payment date, and payment method. The Advanced MD database is able to pull reports, including billing reports, like top carrier insurance analysis report, a hospice report, which shows which patients are on hospice at any given time, financial reports like an AR aging report, which shows how long it took patients to pay their bills, and also a payments received report, which shows the total of payments received and how they came through, whether it was check, EFT, etc. With our added function, we are able to also pull a credentialing report, which shows which providers are credentialing, what their status is, and orders them in status order. Elise is an end user of this database, so she was already familiar with many of its functions. From this experience and our interview with Genevieve's revenue cycle and data manager, we came up with the business rules for our database. Using those business rules, we developed our entities, attributes, relationships, and constraints. From the business rules, we created a conceptual data model. We created 7 tables. One of the tables, appointment_info, is a bridge entity to eliminate the many-to-many relationship between the appointment and provider table. Once we were satisfied with our conceptual data model, we transformed it into the logical data model, where we added variable information and simplified the relationship. Once we had our models completed, we were able to start creating our database, starting with a reset script, which drops all tables taking into consideration primary and foreign key relationships and constraints. We then began creating our tables, which included the provider table, the patient table, the bill table, and the insurance table. Here it is worth noting that the insurance table has a foreign key, patient_number, which references the patient table. Next, we created the payment table, which has a foreign key, bill_num, which references the bill table, and the appointment table, which has two foreign keys, patient_num, which references the patient table, and bill_num, which references the bill table. Lastly, we created the appointment info table, which includes two foreign keys, appointment_num, which references the appointment table, and provider_num, which references the provider table. All the foreign keys that we created establish necessary relationships between tables that will ensure that the database can carry out functionalities with ease, especially when it comes to creating reports that are integral to the practice management. The record insertion process for this project is very straightforward. We inserted records for all tables, determined data types, and ensuring that all attribute information was captured accurately. Unique primary key identifiers were used in each record, and foreign key identifiers were inserted where applicable. We created a total of 5 queries for this database. Our first query is a carrier analysis report that shows our top carriers. By using the aggregate function count, we can determine how many patients are covered by each carrier. It groups Medicare and Medicare Hospice together because both of these plans fall under the same payer. Our second query shows which patients are currently enrolled in hospice. This report shows the patient number, the patient first and last name, and the patient insurance carrier. To create this query, we had to join together the patient table and the insurance table by using a patient_num attribute with a right outer join. This query creates a report showing total payments received broken down by payment method, either check or EFT, electronic fund transfer. It uses the aggregate function sum. Anytime you are working with billing, it's important to be able to track how long customers are taking to pay bills. In this query, we use the dateDiff function so that we could do the math necessary to determine how many days it has been since the patient was sent the bill. If we had more time, we would set up a report that would run monthly that would determine when bills are 30 days overdue, 60 days overdue, and 90 days overdue. Our last query uses a subquery to calculate an average bill that we can then compare to a client's bill. It is part of a fraud prevention measure. We want to track clients whose charges are greater than average. Ultimately, we were very pleased with our recreation of the Advanced MD database and our ability to add 2 additional functions to the existing database. Thanks for listening.